As construction projects grow in complexity, precision, accuracy, and real-time data are becoming critical for success. One of the most powerful tools emerging in the industry to meet these demands is drone mapping, specifically the creation of two-dimensional orthomosaics. But what exactly are two-dimensional orthomosaics, and how do they benefit construction planning and progress monitoring? In this video, we'll dive into the world of drone mapping and two-dimensional orthomosaics, exploring how these technologies can enhance construction planning, reduce errors, and improve team collaboration. We'll also look at the tools and processes that make this technology so effective, and how it can be integrated into your projects for greater efficiency. First, let's break down what a two-dimensional orthomosaic is. Simply put, it's a high-resolution map or image created by stitching together multiple aerial photos, often captured by drones. These images are geometrically corrected so that they represent the Earth's surface with great precision. Think of it as creating a high-altitude view of your entire construction site, but with extraordinary detail and accuracy. Compared to traditional site mapping methods, which often require a lot of manual labor and can be prone to human error, a two-dimensional orthomosaic provides a comprehensive and highly accurate representation of the entire area. It's like turning a pile of paper plans into a dynamic, interactive map. Now that we understand what two-dimensional orthomosaics are, let's look at the benefits of using drone mapping in construction site surveys. The traditional methods of surveying a site, such as using a total station or handheld GPS devices, are time-consuming and labor-intensive. They often require workers to physically visit multiple locations, which can take days or even weeks. With drone mapping, you can cover large areas in a fraction of the time. The drone flies over the site, capturing hundreds or even thousands of images that are then stitched together to form an accurate map. This speeds up the surveying process and provides a level of detail that's hard to match using traditional methods. But the real benefit is in the quality and accuracy of the data. With drones you get high-resolution imagery, and the resulting two-dimensional orthomosaic is precise enough to guide everything from initial planning to progress monitoring. Plus, it helps identify potential issues before they become costly problems, which leads to reduced risks and better project outcomes. So, how do we create a two-dimensional orthomosaic from drone imagery? It starts with capturing the aerial photos. Our drones fly over the construction site, ensuring that we get every angle and critical view needed. From there, we use specialized software to stitch the images together and correct for any distortion. The software corrects for things like camera angles, terrain displacement, and other variables that might affect the quality of the map. This ensures that the final product is accurate, seamless, and represents the real-world conditions on the ground. And once the images are aligned and corrected, we can zoom in and assess details down to the millimeter. One of the key advantages of using two-dimensional orthomosaics in construction planning is the enhanced precision they provide. When planning a project, you need to make informed decisions about materials, manpower, and timelines. A two-dimensional orthomosaic gives you a detailed, real-world view of the site that helps you plan with accuracy. For example, you can use the map to measure distances, assess land topography, or evaluate potential hazards, all with high precision. This level of detail ensures that you're not only meeting deadlines but also adhering to budgets and safety standards. It's about making smarter decisions from the very beginning of the project. Another major advantage of using drone mapping and two-dimensional orthomosaics is how it reduces errors and improves collaboration on site. In traditional construction processes, miscommunications and misunderstandings can lead to mistakes, delays, material waste, or unsafe conditions. With a two-dimensional orthomosaic, all stakeholders, whether they're engineers, project managers, or contractors, can access the same data. Everyone is on the same page, seeing the same high-quality images of the site. This leads to better communication and fewer mistakes, as teams can clearly identify what needs to be done and when, in real time. Let's take a look at some real-life examples of how two-dimensional orthomosaics are being used in large-scale construction projects. In one case, a major infrastructure project was facing significant delays due to inaccurate site surveys. After incorporating drone mapping, the project team was able to quickly map the entire site and spot discrepancies between the original plans and the actual site conditions. In another project involving a solar farm installation, drone mapping allowed the team to optimize the panel placement, ensuring maximum efficiency by identifying areas that would have been missed using traditional methods. These examples demonstrate just how crucial drone technology is to ensuring that large projects stay on track and meet their goals. When it comes to generating two-dimensional orthomosaics, there are a variety of tools and software that are used to process and analyze drone data. Some of the most popular platforms include Pix4D, Drone Deploy, and Agisoft Metashape. These software platforms allow us to convert the raw images captured by the drone into accurate maps that can be used for planning, analysis, and progress monitoring. These tools offer powerful features such as georeferencing, measurement capabilities, and cloud-based sharing, making it easier to collaborate across teams and locations. With these platforms, we ensure that the data we collect is not only accurate, but also easy to interpret and act on. Beyond the planning phase, drone mapping plays a crucial role in progress monitoring and project documentation. As construction projects evolve, it's essential to track progress and compare it to the original plan. With two-dimensional orthomosaics, we can easily compare current conditions to past images, ensuring that the project is on schedule and identifying areas that may need attention. This real-time tracking helps with decision-making and documentation, providing evidence of progress for stakeholders and clients, and helping resolve issues before they cause delays. It also ensures that your project documentation is up to date and accessible at any time. Looking ahead, drone mapping and two-dimensional orthomosaics are only going to become more advanced. The integration of artificial intelligence, machine learning, and even more precise drone sensors will take the accuracy and efficiency of these tools to the next level. We're also seeing drones become more autonomous, with automated flight paths and data collection processes. At Aerial Innovators, we are always staying ahead of the curve. As these technologies evolve, we're ready to help our clients take full advantage of the latest drone mapping capabilities, ensuring your projects are more efficient, cost-effective, and successful than ever before. As we've seen today, two-dimensional orthomosaics and drone mapping are transforming the way construction projects are planned, executed, and monitored. If you want to see how drone technology can streamline your construction processes and improve accuracy, don't hesitate to reach out to Aerial Innovators. Let us help you bring your next project to life with the power of aerial imagery.